Yeah, we're live now. Hi guys, welcome to the first ever of POdii Docker Fridays. Today we're going to have just a slight introduction to Docker containers and Docker images. Hope you enjoy. Thank you. Okay, so here are my slides present. I haven't locked my screen. You guys can be heard. So if anyone wants to ask a question, kindly unmute yourself. Okot, is there something you're saying? I can't hear you. You have to unmute your mic so that you speak. I can't. I still can't hear you. So let me lock to my screen just so any watchers on YouTube wouldn't have such a hard time. So hi guys. You're not going to say hi back, but it's okay. Hi, it's nice to see all of you. So welcome to POdii Docker Fridays. Today we are going to do a slight introduction on Docker. Nice to see Calvin, Okot, Maureen, Angie, Calvin, Linda, Paulette, Jackie, Federico, welcome. Nice to see all of you here. Oh, Santos. Nice to see you, Santos. Nice to see all of you. Okay, so first things first. What is a doc? This is a question out to everyone. So I need about 4 answers on what a doc is according to general knowledge. Yeah, Paulette, you raised your hand like a good student. What is a doc? Unmute and speak. I can't hear you, Paulette. Sorry.
A dock is a place where sheep stop.
Sheep's the animal or sheep?
Sheep. SHIP.
All right. Yeah, makes sense. Anyone else with a different answer? I need you guys to be vibrant. Come on. What is a doc? Yes. It's okay to be wrong. Maybe people are acting shy and we all know you're not. Can't hear you, Linda. Sorry. Have you unmuted? Unmute and then speak up. We want to hear you through your sore throat.
Can you hear me?
We can hear you, Linda. Carry on.
A dock is a place where there are a lot of things. A lot of ships that have cargo.
You're not so far from the truth. Thank you, Linda. That's a trial. One last answer from someone random. What is a dock? Anyone? I'm going to pick someone and it's going to be unfair. Maureen, your definition of a dock?
My answer is just like Paulette's. A dock is a place where
Sheep docks.
Yeah,
I get you. She's trying to explain everything with her hands. So, anyway, have you muted? Okay, please mute. Okay, so all of you are not so far from the truth. And a dock is simply what? Who gave the first answer? Was it Paulette? Yes, it's simply where ships go for loading, unloading, and repair. Yeah, offloading, sorry. And repair and stuff like that. So a dock is a place, it's actually a secured place in water. Yeah, where ships, they kind of like park, just the way you can park in a parking spot when we have cars. That's a dock for ships. Everyone with us? Yeah. Okay. I'm going to ask a question. So, what is a container? We all went through preschool.
A container is something that holds something.
What?
A container is something that holds something.
Okay, something that holds something. We can get a definition better than that. Anyone else? Jack, you haven't talked. What is a container? What is a container? Just unmute yourself and then carry on.
I think a container, it's a abstraction for, not even an abstraction. It has a the whole things together. Yes.
Okay, so something that can hold something.
Yes.
All right. Last answer, Linda. Kindly unmute.
Container.
Sorry, what? Thank you.
A container is can you hear me?
This is so exhausting. Yes.
A container is something that can hold many things. Not only one thing. Many.
Okay, so thank you so much. So, all of you have a brief idea of what a container is. A container will hold something. So, we don't know what that thing is. Could be gas, could be something solid, could be liquid. That's a container for us, okay? So, a container is a standardized unit of holding or transporting something. So, we've seen what a dock is. We've seen what a container is. A docker is someone who does things on the dock. Sorry. So we've said it's the repair, the offload, the onload. That's what a docker does. A docker is the person. So can someone confidently stand up and put docker and container in one word and tell me what it could mean? In one sentence, I mean. We've known the definition of dockers, we've now known the definition of a container. Try to integrate the two. Paulette or Linda. If I pick Paulette, Linda will get mad. So you decide. Okay, Paulette.
A docker is the person who uses a container to carry out the actions in the dock.
Okay, good enough. Thank you. Anyone else? Okot, you're eating more than you're answering questions. So give us even a weird answer.
Sorry, you said I put Docker and Wikipedia.
You're not even listening. So we know the definition of Docker. We now know the definition of a container. Try to integrate that. How can they work together?
A Docker is somebody who is at the dock using container to carry things. Okay, the things inside the container, right? Yes. And then there's dock. And then there's dock. After things have been offloaded from the ship, the docker is somebody who carry them.
He's so correct. He's more correct than any of you. So trying to put the two together. What? Yeah, exactly. So what if we had a container and inside this container we could do the same thing a docker does, right? We can unload the container, we can offload the container, we can repair the container. Kevin, I'm being told you've given an answer. Someone read it out to me. Yes, Linda.
A docker manages a container in the dock.
A docker manages a container in the dock. Yes, perfect. That also makes sense. So none of you is wrong. All right. There are different definitions. Whenever you give a question, there could be different definitions of the same thing, and that's where the contrast may come in. Okot, do you have something? All right. So let's move next. So a Docker container, first of all, it's an open source software platform. Okay, it's open source. Who can tell me the meaning of open source? Or better yet, who doesn't know the meaning of open source? Who doesn't know the meaning of open source? You don't know. All right, Angie, since you know, what is open source? You didn't raise up your hand, so give us an answer.
Open source is software that can be acquired by anyone. You don't need permission.
Awesome. Jackie, since you didn't know, are you answered? Okay. All right, so Docker is an open source software. What it does is it creates, manages, deploys virtual applications. So you see the content of the container that we were talking about, the ship. When it comes to the dock, it comes with cargo. We can't tell what is in there. No. But in our case, we're looking at that cargo as code, as applications. Okay. So that is what we're going to be shipping out. That's what we're going to be deploying and stuff like that. So it may be compared to a virtual machine. I'm going to talk about that in a few. And it runs on a Docker engine. I'm also going to talk about that in a few. Any questions until there? No questions. Silence means everyone is okay. Okay. So let's take a sneak peek at virtual machines. Sawa? A virtual machine is also a software program. Okay. There's a time, I think, at any point in our lives, we've known about software and hardware and operating systems. So there's a way that an operating system can be divided into many instances of the operating system. These instances are the ones that are called virtual machines. Okay. Are we clear? All right. So it exhibits behavior of a separate computer. When I have a virtual machine, I can use my computer here as it is and have like 3 virtual machines. But each of them will work as though it's a separate computer on its own. So that's a virtual machine for us. Multiple VMs, virtual machines, can exist within a single computer. I've just said that. A computer where virtual machines run is called the host. Any of us is having a host in front of them right now. So when we're talking about virtual machines, we won't, in many cases, call it a computer. We'll call it a host. All right. So each virtual machine is called a guest virtual machine. If I have 3, then the first one will be called the first guest VM, the second guest VM, the third guest VM. Sawa? All right. So what's the major difference between a virtual machine and a Docker container, isn't it? So Docker, the major difference between the two is that virtual machines, what they do is they come, for example, we talk about a host being a computer. They create a different instance of the operating system, just as I have said. But when it comes to Docker, it uses one operating system. It uses one kernel to host each and every application that you're running. So Docker runs on the Docker engine. This Docker engine is the one that communicates with the computer, all right, or the operating system. On the other side, the virtual machines, they run on something called a hypervisor. So the hypervisor is also what communicates with the operating system, okay? So the hypervisor is the one that coordinates the virtual machines having different instances of the OS. But for Docker, the Docker engine, it doesn't split the operating system into parts. It uses it as one. Okay, so here's the major difference. So on the left, I don't know if it's on your left or on your right, the containerized applications. So there's the infrastructure, which in my case, I was assuming is the hardware. And then there's the operating system, and then there's Docker. And in Docker, we can have different apps running on different containers, okay? So on the other side, we can see the virtual machine also being separated into 3. Each virtual machine is running an application on its own, isn't it? So compared to Docker, where we have Docker and it's all the applications are sharing one Docker engine, the hypervisor is being split into different instances of the operating system just so it could run applications. So that's why most of the time Docker is mostly preferred to virtual machines. Okay. Any questions? Yes. Please don't ask me a hard question, but carry on.
Okay, I have a question.
Yes.
It's concerning the two.
All right.
So, okay, in the first image that is on my left, right?
Yes.
And then there's the other one on my right.
Mm-hmm.
Okay, I'm seeing a host operating system here.
Yes.
And then on the other side, I'm seeing a hypervisor.
Yes.
I don't know. Why is the OS the OS is being split on the virtual machine side? And
The operating system. You see the guest operating system where it is just after the hypervisor. So virtual machines, they split the operating system into the instances. They don't use an operating system as one. So if I have 2 virtual machines, it's like I'm using 2 operating systems, yet in the real sense, I have 1. Does it make sense?
so this is the hypervisor. What does the same? What does the splitting? If I'm correct, that is.
I'm thinking so. That's how I assumed it. Anyone with a correction? Federico, come to our rescue.
Could you repeat the question? I was listening, but I wasn't looking at the video. The question was, what was the question, Okot?
Okot, can you repeat this question?
Okay, on my left-hand side, I can see operating system clearly that at the bottom. On this side, I'm just seeing the split operating systems. I'm not seeing a very vivid picture of operating system. What I'm seeing are the split ones, the guest operating system. So what I was wondering is the hypervisor doing the splitting, and where is the operating system on the infrastructure itself?
Okay, yes. So with Docker and with containerizing, you're still using the exact same host operating system, and it's using the host operating kernel. And what what Docker does is it sort of sections out a section of the kernel and the operating system for that container. Whereas with hypervisor or like for VirtualBox, it puts up a brand new guest operating system like you have here, and you would have to use more than one, like you're showing here clearly, operating system. Where with Docker and containers, you just have that one. I'm not sure I answered your question though. I think I tried to shed some light on it, but do you have a follow-up question? Or maybe you can continue if that makes sense.
So I know my question is what is not making sense, because what I'm seeing is I'm seeing an host operating system in the Docker side, just underlying there. But on this other side, what I'm seeing is hypervisor. I'm not seeing an host operating system. I'm seeing the hypervisor.
Yeah, I see. I think it's implied though. Like you still have the host operating system implied there. Yeah, so it's still there on the right, because obviously you have to run your hypervisor on something, your host.
Yeah.
Hopefully that helped a little bit.
Okay. So Sigu had an explanation. Sigu, this one. Say hi to Federico.
Hello, Federico. Hello, guys.
It's a good. Hey,
Yeah, I'm in the background. I'm just trying to finish up on a few things for tomorrow's event. So that's why I'm just listening in. So, Okoth, you're asking about the hypervisor, the infrastructure, and everything. So what happens in the virtual machine world? A virtual machine is a whole operating system inside the operating system. Okay. So if you have Ubuntu, if currently you have Ubuntu 18.04 and you have a virtual machine for Windows 7, it brings in everything for Windows 7 into your computer. If you need Ubuntu 16.04, then it brings in everything as a whole operating system right here. Okay. So it has, sorry, where am I? Okay. So it brings everything. Let me use this. So it brings in everything for the operating system. Okay. Now, for all this to happen, for all this to work, your guest operating system needs something called a hypervisor. This is running inside your guest operating system, your host, not guest, your host operating system, which is the Ubuntu you have in your machine, what you have installed, not inside your Ubuntu. So your host operating system is what you have running in your computer. The guest are the little operating systems that you have inside the host. So it's hosting the other ones. So the hypervisor is running inside that. A hypervisor can be something like VirtualBox, VMware. They enable the environment for you to be able to run virtual machines. Okay. The infrastructure is the bare metal. A bare metal is the actual machine, what you can touch, the hardware, if that makes sense. Now come over to Docker. So what happens is you install Docker in your host operating system. Over here, you needed a hypervisor. Over here, you need Docker on the host system. Okay. What Docker does, it shares resources with your host operating system. This came with a whole operating system on its own. So Docker checks if app A needs your kernel or whatever it needs from your host, it will share with it. Any new thing, it will get it. This doesn't care what you have. It installs everything, even if you had it over here. So you'll have everything installed on this, everything installed on this, everything installed on this. But for Docker, it will share with the host operating system. And if it found anything that was existent in your host, again, it can share between app A and app B. So the images tend to be smaller for this because you already have the kernel in your machine. If you check on your kernel version, okay, if you check, let me just zoom in. It's appeared. Where is it? I don't know what I'm doing. Okay, so if you check on your kernel version, I think that's a command. Yes. So you are on which Linux now? 4.4. So you already have a kernel. So if you need a machine that needs a kernel, then this one won't install kernels because it will use the kernel for your host machine. This installs the kernel. This will install its kernel, its kernel, its kernel. Application. Everything will be duplicated. That's my long explanation of the difference between the two. I don't know if it made sense.
Thank you. It made a lot of sense.
Thank you.
I do have like a diagram to show you guys.
Alright.
That might help out a little bit. So the way that, yeah, just quickly, thank you. The way that I've learned Docker is through Stephen Grider. Stephen Grider makes awesome courses. And if you look at the kernel gives you access to like your infrastructure, to your hardware. And so a container, this is one of his diagrams. A container, instead of setting up a whole new, like Siga was explaining, a whole new host, a whole new virtual machine on top of your host infrastructure, it uses your exact same kernel and it sections off a portion of it for that container. So where you have like this app running in your container, your Docker container, it will be given access to the hard drive, to the CPU, within that section of your host operating system. Hopefully that helps. Maybe you have more images like this, but I found this one particularly to be very helpful to understand how containers work. So you can continue. Thank you.
Thank you, Federico. Thank you, Sigu. Okoth, is everything okay?
Yeah.
All right.
Yeah, thank you.
All right. So I think it's safe to say Docker is like the new face of virtual machine, isn't it? It just makes virtual machine having to have different operating systems better by reusing the same resources, right? So according to how I see it, Docker is just like the new girlfriend in town. Okot, you had something?
I say, okay, I think from what I'm seeing, Docker, like, it helps you in managing the resources. Instead of, it's a resource manager that is.
Okay. Thank you. So next, hopefully everything is okay with everyone. Okay, so here are the differences between Docker containers and virtual machines, okay? So for virtual machines, runs on the hypervisor, each virtual machine having their own instance of the operating system. Hence, each of them runs as an individual entity from the host, just as we had seen that each and every application is going to run as though they have their own, they're running on a separate computer from any other virtual machine, okay? But for Docker containers, they run on the Docker engine with a shared kernel. So this makes the containers smaller and I think easier to manage because it's portable, first of all, and then enables a faster startup with better performance, less isolation, great compatibility, and low system overhead. So I'm thinking all these advantages come because of the shared resources thing, right? Because I can have different containers sharing the same kernel. This means the memory allocation doesn't have to be for every, like the way virtual machines do it. We can have a shared memory. We can have, when there's a book I was referring to, when he talks about less isolation for Docker, it was more on the software than the hardware side, because there's a point he talked about the disadvantages of having Docker over virtual machines was the isolation between the hardware isolation. So in that case, less isolation was a disadvantage because he was saying that when it comes to separating hardware, just like, or was it sharing hardware, just like virtual machines do, that's an advantage to them. But for Docker, we don't have that, the separation when it comes to hardware resources being shared or something. Didn't quite get it clearly, so. All right, and sorry, Okot. Okay, so greater compatibility. I think this is when it comes to Docker containers can be moved from one host to another host, right? So when I move it from Moju's computer to Angie's computer to, what's your name? Sorry, Jackie's computer, it's going to run the same way. So there's never going to be compatibility issues because it's the same Docker container, same Docker image. All right. So there's more advantage in using Docker containers as compared to virtual machines, just as we have seen. There's obviously some hurdles in using Docker and some advantages in using virtual machines. But when the good beats the bad, we go with Docker because it has more advantages over virtual machines. Any questions? All right. Let's talk about Docker images. A really interesting thing I found about Docker images was that a Docker image is converted to a Docker container at runtime. A Docker image is converted to a Docker container at runtime. So when we create images, or we've used images before, like the Alpine, Ruby, the images. So at runtime, they're converted to containers. The containers we've been talking about since start. So that's what happens. So a Docker image is lightweight, standalone, and it's executable on its own. Okay. So it's like the way we talked about the ship carrying around everything that needs to be done, the offload, the onload, and every other thing. So that's how I understood it from there. It includes everything needed for that app at runtime. Okay. This, for Ruby, we can say the gems. For Elixir, we can say the dependencies. Every other thing that is needed for an application at runtime is included in the image. Okay. An image will always run the same regardless of the host. Just as I have explained, it's very rare to find compatibility issues when it comes to moving from one host to another, because a Docker image or a Docker container will always be that container, right? Yes. Okay, so isolate software, in different environments. So you can run your Docker image or your Docker container in development mode, staging mode. The two environments are literally separated in that when running at staging and running at development, they don't interfere with each other at all. Okay, any questions? Yes, Mojo. Let it be an easy one.
According to the way you have explained about Docker images,
Yes.
okay, I want to relate with Flutter. So I want you to explain to me in terms of, of Flutter so that I can visualize, because I'm not understanding.
Okay, so I really wanted to explain, but Scott has offered to, so I'm going to leave it to him.
Okay, thank you.
So in this instance, like she just said, an image is a standalone executable package. In this case, Flutter will be the image. Yeah, so I don't know whether that makes sense from your perspective, but it's an executable package.
Actually, I remembered something, but you weren't there when Sigu was explaining it to us yesterday. Like, you see the different steps that you have to go through to like install, let's say Flutter. You do install Flutter. Like you have to install it and execute and all that. All that can be placed into an image. Someone correct me if I'm wrong. That's why they're saying at runtime, that image does all that is supposed to do. Does it make sense? Hakot?
It makes sense. Okay, what Sig was explaining yesterday, from what I derived, is that an image, you can either, okay, you can put it in your, you can set it up on your own, or you can just pull it from the Docker Hub where already somebody has set it up. For instance, when you want an Elixir image, you can either use already deployed on the Docker Hub, or you can set up your own on the local, on the locally, that is, you can set it up.
Okay, so Linda, do you want to speak? Like the way you've given us two options, it's either I install Elixir or Flutter on my computer or pull it up, right? Is that what you've said? On my app, I'm sorry. So the process that I'm going through, installation and extraction and all that, I think when we talk about another person who's created that image, isn't that the process he went through to create that image? I don't.
The image is the final thing, yeah? Final thing is the image.
Yes.
Not the process.
Okay.
Yeah.
We're saying the same thing differently. Okay. Yes, Linda, just say it. Just speak your heart.
Um, from what I gathered is that I will use an example of Elixir. When you want to install Elixir in your machine, at first you have to know which type of operating system you're using, and from the operating system you're using, you have to go to the requirement. I don't know. You download Elixir, right? Using a command or yeah. So a Docker image is a final package, like a whole package. But the process of going through the image is telling the is okay. A Docker image is a set of instructions on how to do something. So if you bring an Elixir, if you want to put up an Elixir image, it's like if you want to set up an Elixir image, it's like you're telling this computer, you're telling Docker that, okay, I'm using Ubuntu, or I want the Alpine one, and after that, install a sudo update, install Elixir. After installing Elixir, you put all these things. So that is an Elixir image. So an image is more like a set of instructions on how to reach to a final package.
Okay. Thank you, Linda. Makes sense. Okot, I had you on mute. You have something else? Okay.
Maybe I got it a little bit confused, and I don't know because yeah, what I was thinking an image is like, for example, in this case, Elixir will be an image in its own.
Mm-hmm.
Yeah. So you install Elixir image, and then you install the. I mean, Ubuntu will be an image on its own. Elixir will be an image on its own. If okay, I stand corrected though. So you install the Alpine, for example, image. Then you install the Elixir image. They're totally different images. That is.
Yes, they are.
But from what I'm gathering from Linda and you is that an image is the process entirely, like the entire process of taking Ubuntu, Elixir, and then placing them together to form the process itself.
I think what Linda said is the image holds instructions. Did you say something like that? Like the algorithm that goes through for you to be able to install Elixir into your, say, machine or your app. So I'm thinking if it's Elixir, you'll get things like sudo apt get install Elixir, extract this, install this, I think. So all those instructions are the instructions that are placed in the Elixir Docker image, in that when I run it in my computer, it runs those things for me. I don't have to do them on my own. You seem very, very unconvinced. Uh-huh.
I want to know is what is an image? Is the image Elixir or the process?
God. I'm sorry, but an image is more like an environment. An environment, you can now run like the Elixir environment. So an image brings the environment. That is what I think. But the component of an image is the set of instructions that will actually make the environment. In your machine, you can do IEX, right? And it will run. What was the process you went through installing Elixir? You obviously did a lot, right?
Yeah.
Yeah. So an image contained the set of instructions or guidelines on how to install something. Then the final image is now kind of an environment. Your computer has the Ruby environment. That is why when you run IRP, you can get the Rails console. So when you do IEX, when you do IEX, you can go to the Elixir Yes, interactive shell. When you do Python, I don't know how you people open up your your interactive shell. You get the environment. So a Docker image just brings the environment.
Could you get a better explanation than that? He's coming up with another question very soon. Are you okay, Okot? If you're not answered, feel free to ask more. You're okay. Okay. People, he's okay. It's a miracle. Okay. So, here are the advantages of Docker images. So it's standard. It's standard in the way that I actually mentioned before. It's standard in that I can use my Docker image on this host. I can use my Docker image on Jackie's host. Like it's standard, and I think the point standard just means it's portable. Like a Docker image here is the same as the same Docker image on anyone else's computer. It's kind of like an atom in Elixir. Okay, so it's lightweight. So by lightweight, I mean it's one thing to move around. That's how I got it. Like instead of moving around this many things, I'm using my hands to describe this many things. So sorry for those of you who are online. This many things to carry around is harder than placing them in one container and shipping them. Like the same, we go back to the dock. If at all we didn't have a ship, for example, or a container, we'd have to transport those things, I don't know, by water, or I just don't get it. But it would be much harder than to have to transport them in a container. And then it's secure. I mean, I have never had an instance where, excuse me, I have never had an instance where a Docker image was hacked. I don't know. I don't know. This is my take. So it's secure. If your application is on Docker, you know that you'll always find it there. Okay. Did you know? Okay, someone read this out for me. I'm coughing.
I can read it for you.
Calvin or anyone else?
Yeah.
Oh, sorry.
So did you know that Docker first flourished in Linux and that later on drove a partnership with Microsoft? And did you know that now we have Docker containers on Windows servers? I mean, I knew that. Did you guys know that?
Ah, please, you didn't. We know you didn't, but anyway, thank you. Yes, so that's just something to note. So everything that starts on Linux flourishes. That's the key point to note. So anything that starts on Linux will always be copied by Windows. We're proud. All right. So it's easy to put your app on a single container. Next time I'll show you how. And that is my presentation for today. Any questions? I'm sorry about my slides. I like my slides really playful. So if there are no questions, I would like to bring this meeting to a standstill. Thank you everyone for joining me on the first ever POdii Docker meetup. I hope to see you on the next one, which is after a month. Kevin, I heard you typed something. Someone will read it out for me. Thank you. Who's going to read it out for me? Federico already read something, so I'm not on his case.
I mean, I could read it again.
A Docker
Right.
container unit is a lightweight standalone executable package of software that includes everything needed to run an application: code, runtime, system tools, system library, and settings. The definition is from Docker Resources. What is a container?
Oh, nice. Thank you, Kevin. That's the add up on what we just learned. Thank you. All right, Federico, you have anything to add on top of the Docker meetup?
Well, I mean, I would say very good presentation. So, and I like the slides.
All right, thank
So
you.
you don't have
I
to.
get that
You
a
don't have to.
lot. Sorry.
You don't have to. You don't have to apologize about that. I did. I did find these other diagrams from Stephen that might help out, because I was kind of thinking of an image more like a class and like a container, like an object. You know how a class can be like a blueprint, and then a container can instantiate it. But I don't think that fits completely, because I think an image is more like a snapshot that you can
Yeah.
sort of spin up into a container. And his definition is an image is a single file with all the dependencies and configuration required to run a program. A container is the instance of an image. It runs the program. And then there was this other, this other one over here. This one kind of is that previous diagram that I showed you on the right, but this is over here on the left. An image is a file system snapshot. So it's like you froze your Linux computer, and with all the files, you froze it, and with a startup command. So when you actually run the image, spin up the container, it'll run, for example, here, it'll run Chrome. And then when it's actually running, you have Chrome running here. So I just wanted to add those. I was looking through these slides, and those were the two best ones that had to do with images and containers.
All right. That is helpful. Can we have those images? Can we get them?
Yeah,
or
so
we just Google?
I would recommend you download draw.io, because they are diagrams.xml. What I did is I'll post this link here for you guys. This is from his course, and then they're in here in diagrams, and they were in the first one here. It's this file right here, diagrams.xml. And then what I had to do is I actually clone the repo.
Oh, the whole repo.
Yeah, and then I opened it. Yep. So I'll post the link here for you guys.
All right. Thank you very much, Federico.
Yeah, no problem. Thank you.
Okay. Anyone else with anything to add? A parting shot?
Yeah, Federico, I heard you were looking for a designer. I have Getty here. She can do a better job.
Yeah, okay. Yeah.
He's not looking for a cartoonist. He's looking for a designer. All right. Thank you.
We'll talk later.
Yeah. Okay. So if there's no other thing, thank you guys for joining me on the meetup. I'll see you next time. Next Friday, we'll be having Python. Yeah, so Python Fridays. Okay, thank you so much. Bye.
Thank you. Bye.